Hey GED students, it's GED question of the day time, and we've got one of those dreaded word problems. Let's take a look. It says Flora is making goodie bags as party favors for her daughter's birthday. Yeah, super special Flora, but definitely not math. Okay, she wants each bag to be identical. Okay, that's important. Identical, equal sized, same number in each bag. That's a math concept. So none of the children squabble over bags. Flora has 24 party favors. Whoa, what just happened? Flora has 24 party favors, 40 candies, and 16 plastic rings. Numbers are useful in math. What is the largest number of identical bags she can make? And here's the important part, using all of her supplies. So she wants to take 24 party favors, 40 candies, and 16 plastic rings, and she wants to make identical goodie bags, meaning she wants to break these things into equal size groups. Notice we want to make the largest number of identical bags we can make, meaning we want to find the largest number that can divide all of these three. Breaking something into equal size groups mathematically means to divide. Now you might be thinking, Kate, how in the world am I going to do that? Well, this concept, the largest number that can divide a bunch of numbers, has a name, and we've been working with it. It's known as the GCF. And they might have never said the greatest common factor or greatest common divisor or any of that language we're used to in this word problem, but they did ask us for the largest number that can divide all these numbers. That, by definition, is the GCF. So they're asking us to find the greatest common factor of 24, 40, and 16. Now, I'm going to use my lovely GCF trick. If you want a full explanation of this, take a look at some of our previous greatest common factor videos. But basically, it allows me to take out any factor and then build my way up to the GCF. So even if you don't know the largest number that divides all three of these, you might know a number. So I notice 4. I'm like, oh, all those numbers are on my 4 times tables. So I'll divide 4 out of each of them. So 24 divided by 4 is 6. And I write down my remaining number here. 40 divided by 4 is 10, and 16 divided by 4 is 4. So these are the numbers that I get, 6, 10, and 4, when I take out that common factor of 4. But you should keep considering, do these three numbers that I have left have anything in common? Well, one thing I noticed about 6, 10, and 4 is they're all even, so they must all be divisible by 2. They're all in the 2 times tables. Let's divide them all by 2. 6 divided by 2 is 3, 10 divided by 2 is 5, and 4 divided by 2 is 2. Now examine the numbers we have left. 3, 5, and 1. Is there any number... Whoa. I'm having all kinds of tech issues today. Is there any number that can divide 3, 5, and 2? The only thing I'm going to be able to divide out of 3, 5, and 2 is 1. You know, 3 is divisible by 1 and 3, 5 is divisible by 1 and 5, 2 is divisible by 1 and 2. Really, the only thing that'll divide them perfectly is 1. And always I say 1 and done. As soon as the only thing that you can take out of all three numbers is 1, you're done finding your GCF. That means there's both a 4 and a 2 that all three of these numbers have in common. So we're building the GCF factor by factor. So we found a couple of common factors here. And what we're going to do to find the greatest common factor is just multiply all the common factors we found together. So 4 times 2 is 8. So the GCF of this problem is 8, meaning we can make 8 identical goodie bags. And that's the most number of goodie bags we could make using all of these supplies. Great. If you have any questions about this or any of the GED concept, be sure to drop it in the comments and I'll do my very best to answer it.